Okay, everybody. It looks like there may not be anybody in tonight's session. And so since a bunch of you watch it via the recording because you work at this time, I'm going to go ahead and get started. And there just won't be any interaction between me and any other students unless somebody joins in. So you have due tomorrow 2 sections, section 7.R.3 and section 7.3. This one can be fairly lengthy and they're very intertwined. So I'm not going to have any kind of distinction between one and the other. We're just going to kind of do some problems and you'll see them in one place or the other. So what we're going to do is start out with a couple of things that are not typical to math. They're not actually solving a problem. So your goal isn't to find something like x equals 12 or anything like that. Your goal is to simply make it look in another form. So on these two, I'm going to tell you that your instructions are to change the radical to exponential notation. And this is going to be particularly helpful when we get to things that are solving. It's going to be a skill that you're going to need in the middle of that. So we're just going to practice this for just a second. And it looks kind of weird and there's a bunch of numbers running around. So this is going to look like this. Now, I purposely didn't tell you how to say it because I want you to realize something. That little 5 on the outside of here, that is a root. So you would say the 5th root of x to the 7th. So the number that's on the outside is the root, and the number that is the exponent is the power. And anytime that you are changing that to exponential notation, what that means is you want to get rid of that radical sign and you want to just have exponents. And the way that this is going to look is it's going to look like x to the 7/5. And the reason is because it's always, oops, let me kind of scratch that out for a second. Power on top, root on bottom. And then, and that's it. You're not trying to solve or anything on these. We will get to that at some point, but not right this second. All you want to do is take it out of that radical notation. And what radical means is that you have the little house looking thing. And then exponential notation means you have nothing but an exponent. So if I were to give you this one for just a second, you would say that this is the 3rd root of y, or you could just say, sometimes people call the 3rd root the cube root. So you would say that that's the cube root of y. Now, what I want you to realize is on this particular problem, there is no power with the y like there was in problem number 1 up there. So if there is no power, it's an understood 1. So right here, there is a 1. And so when we write that into exponential notation, it would be y, and then remember it's power over root. And so that would be y to the 1/3 power. All right, and so hang on just 1 second. It seems that my whiteboard does not want to erase. So we are going to stop that share and we are going to get into a new share here. And there comes my eraser back. All right, that was a little bit better. I'm not quite sure where my eraser went. All right, so that was just changing a root or a radical to an exponential. And then what we are going to talk about is we are going to talk about some logs. And so y'all are going to be starting to work with a lot of things that look like that look a little different than you have probably seen before. So I want to talk to you, and this is a very crucial skill, about how to convert between log and I'm going to abbreviate here because I'm running out of room over there, exponential form. And so I'm not even going to call these numbers. I just want to talk about a few things. So for the first thing I want to do is just put numbers with something. So this is going to be a pretty simple exponential equation. So I want you to look at this for a second. We could, if we wanted to, solve this for x, and we will in a little bit later today. But this is why this is an exponential equation. The reason it's called an exponential equation is because it has an exponent in it. And so it really has three parts, and these are vocabulary words that it would probably be easier if you remembered. So the thing that is being raised to a power is called the base. So the 5 is the base in this problem. And whatever the power is, we know that word as an exponent. And then for lack of a better word, I'm just going to call this the answer. So this exponential equation really has three parts. It has a base, has an exponent, and it has an answer. Well, now exponents and logs are just inverses of each other. And I know it's been a while because that was before your midterm, but we did inverses in this class. And that's where you take your x and your y and you flip them. And so logs and exponentials are exactly the same thing. It's just a different way of writing it. And sometimes it's easier to solve for x if it's in a log form, and sometimes it's easier to solve for x if it's in an exponential form. And so when we get into all these solving problems, you're going to be going back and forth between these two things. So we need to learn how to do that. So the way that you do that, if we're going to start with an exponential equation, is you start by writing the word log. So we want to take an exponential equation. We want to make it look like a log. So there it is. It's a log. Now, every log has a base. Notice our exponential had a base. So since this exponential equation's base is 5, my log's equation base is also going to be 5 because remember, they're just a different way of writing things. But the way that we write the base in a log is a little subscript right after the log. And a subscript literally means small and lower. So it's not going to be written, it's not going to look like this. So I don't want y'all to think this. Don't write log and then write a 5 right next to it. Nope, 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 nope. Can't do that. It's right after the word log, but it's literally lower than the log is right there. So log base 5. And then remember, these are inverses. So what they're going to do is they're going to take our exponent and our answer and switch them. So we're going to be taking the log base 5 of 25, and we're going to say that equals whatever our exponent was, which in this case is x. Now, if you have not dealt with logs before, this thing over here on the right of my screen looks kind of funny. You probably like the first one better, and that's okay. Just when we get into these things, it's going to look a little bit different. So let me give you one more just to kind of show you, and then we're going to go backwards. So if I had something that looked like x to the 3y power equals z. Now we know that that is an exponential equation because it has an exponent. So if we want to make that a log equation, we would start with the log. We would check whatever the base is over in that equation is the base here. So it would be log base x. And then we take our exponent and our answer and we just flip them. So it'd be the log base x of z, and then it equals whatever my exponent is. In this case, that would be 3y. Now we're going to do this, the exact same thing. So I probably should have just left those instructions up there. But what I'm going to do now is I'm going to go backwards for a second. Instead of starting with an exponential equation, we are going to start with a log equation. And we're just going to make it look like an exponent. So no solving yet, just flipping it around. That's it. So if I started with a log and I said, okay, the log base 12 of x equals 2. Now, the way that I know that that's a log equation is because it literally says log in it. So you always want to start with your base. So remember, your base is right after the word log and it's lower. So my base here is a 12. So we're going to say 12, and then we're going to raise it to this power. So 12 to the second power equals x. Now, I really want you to stop and think about that for a second. You can solve that immediately. You might have looked at this log base 12 of x equals 2 and thought, oh my goodness, I don't have an idea what that means. Well, that's okay, because if you can switch it over, all this says is, hey, 12 raised to the second power is x. Well, you know what 12 to the second power is, and that's something that you can solve. All right. Now, there are two tricky logs. We're going to talk about both of them. So here's the first one. The log of x equals 4. Well, if you don't remember or having seen this anyplace else before, you look at that and think, okay, they've written me a bad problem because they're missing something. So if you're really on your toes, I want you to think about, what are they missing? Well, there's no base. If there is no base, and this is crucial, you need to know this. So if you're watching this later, I'm going to tell you, pause your video, write this down. If there is no base, it is an understood 10. So you can write the 10 in. Now, the math books won't, because it's easier not to, but you can. So if it just says log with no base, put a 10 right there. The base is a 10 if they don't give you the base. And once you know that, then you can come over here and you can switch it over to exponential form and say, hey, that is my base 10 raised to that power 4 equals x. Now, I told you there were two tricky ones, and I wasn't kidding. So here's your next tricky one, and it looks like this. The natural log of x equals 2. And that is not a real good color, so we're going to switch back to red because that doesn't show up well. So natural log, notice there is no base, but it doesn't say log, so it's not a 10. ln, if you don't know what that means natural log. So I have always told people I don't understand why they didn't write it NL, but they didn't, and I didn't make the rule. So I want you to know that the natural log, I'm going to take that out, is the exact same thing as the log with a base of e. Now, since you've already done your section 7.1 and your 7.2 homework, you remember using e on your calculator. E is just a number. It's not any variable that you have to solve for or anything like this. So if we were to switch this over, it is e raised to the second power equals x. And remember, that E button is on your calculator. So all you would have to do is find that button wherever it happens to be, because it's in different places on different manufacturer calculators, and just raise it to the second power. All right, so let's start on some actual things where you have to do some solving. And most of the ones that you are going to come across today that you have to solve are going to involve switching over from one form to another. So the first thing that you are likely to see is something with the instructions of this. They will say evaluate without a calculator. Now, that literally means don't grab a calculator. If I put this on the test and you grab a calculator, I'm not going to give you any credit for it. You're going to have to show me the work behind why this works. So we're going to start with some that are a little bit smaller numbers, and then I'll do something that's got a little bit bigger number in just a second. So here's the first one. The log base 4, oops, let me erase that. So sorry. Base 4 of 16. And then they just put in equals. So the question is, what does it equal? Well, if we knew that, we'd know the answer. So what I'm going to do is I'm just going to say, well, I don't know what it equals. So for a minute, I'm going to say, well, let's pretend that it equals x. Okay. And then if I can find x, that's great. So the only thing that I have talked to you in the last, 5 minutes is how to take a log and make it look like an exponential. So that's what we're going to do. So we always start with our base. So the base here is 4, and we're going to raise it to this power, in this case, x power equals 16. And so we're going to ask ourselves, What can we do to 4 to raise it to a power to equal 16? Well, you probably know, you can kind of run through, if you don't know your powers, just run through them over here. 4 to the first is 4. 4 to the second is 16. Well, here we go. Look, that's what we were wanting. So what is x? X is equal to 2. And so what that means is that you now know that the log base 4 of 16 is equal to 2. So let's try a different one, okay? How about the log, this is a little bit of a bigger number, base 5 of 125. Now you'll notice it is exactly like the problem above. So I'm going to do the same thing. I don't know what this equals off the top of my head, guys. So I'm going to say, I don't know. It equals x. And then I need to find x. So once I have something on that other side, I can take this and change it over. And I can say, okay, to change it to an exponential, that would be 5 to the x power equals 125. Well, once again, you need to know, okay, well, 5 to what power equals 125? Now, if you're really good with powers, you may know that off the top of your head. Nobody ever said you had to be good with powers. So if you're not, just run over here to a little scratch work and let's do that again. So 5 to the first is 5. 5 squared, remember that's 5 times 5, so that's 25. 5 cubed, this is getting kind of big. Remember that's 5 times 5 times 5. If you don't know what that is, grab a calculator, and that is 125. And so that'll tell you that in this particular problem, x is 3. All right. So let's try something along the same lines, but this time it's already going to come to us in an equation form. So these really weren't equations to start with. We just kind of set them equal to x, and that made them look like equations. So on these, they're going to come to us as equations already. So let's look at something like this, and we're going to start out pretty small, not a lot of algebra here. The log base 3 of x equals 4. So that already is an equation or a number sentence because you have something on the left, something on the right. And so what we know so far, the only thing that we really know is how to switch it around. And so what I'm going to do is make this log look like an exponent. So we're going to start with our base, 3 raised to the 4th power equals x. And then all we have to do is evaluate that. And so you'll notice over here we have 3 to the 4th power. Remember, that means 3 times 3 times 3 times 3. So 3 times 3 is 9, times another 3 is 27, times another 3 is 81. And so we just get 81 is equal to x. Now, there are some that have a little bit more to do. Now, not necessarily a ton yet. We're going to get to some next week that are really detailed, and you'll be doing this in the middle, and you'll be doing a quadratic and all that kind of stuff. But right now, today, not too terribly detailed. But let's look at this one. So the log of x minus 4 equals 2. Now, this one has two kind of things that we really haven't done a lot of tonight. The first is, notice right after the log, what's not there? Well, there's no base. Okay, so remember that thing that I told you if you were watching this later to stop your video and write it down because it was important. If there is no base, you have to know what it is. And if there is no base, it is a 10. And so I will tell you, I've been teaching algebra for way longer than I care to admit because it would tell you how old I am. Okay. But that is something that students forget. And so if I can impart one piece of advice to you, when you see a log with no base, just write it there. Write 1, 0. If you see the base, you are likely to do better. So now that we know that the base is a 10, we're going to do what we did on the last problem. We're going to take it out of this log form, put it in exponential form. So we're going to say 10 raised to the 2nd power equals x minus 4. Now you'll notice this one doesn't have the x by itself. We're going to have to get there. But before you do that, do your exponent. So 10 raised to the second power, remember, doesn't mean 20. It's not 10 times 2, it's 10 times 10. So 10 times 10 is 100 equals x minus 4. And then remember, your goal is to solve for x. So you got to get x by itself. Well, the way to get x by itself is to move that minus 4. And the way to do that is to add 4 to both sides. Those cancel. So what we get in this problem is 104 is equal to x. So you'll notice over here you had to do maybe just a little bit more algebra, but it wasn't that bad. It was just adding something, and so you can do something like that. Now let's try one that's got a fraction. And I know fraction is the math cuss word for most people. Okay, so I figure if there's a chance that you're going to see it on your homework, there should probably be a chance that we talk about one here. So even though this is going to have a fraction in it, we're not going to treat it any differently. So the log base 1/2 of x equals 4. Okay, so here we go. It's got a base, so we don't have to put in a 10 or anything like that. So now what we can do is we can take it out of log form, put it in exponential form. So we start with that base. So 1/2 raised to the 4th power equals x. Now I'm actually going to take the time to write this one out because I want you to really realize what's happening here. And I just made a mark on that screen. There we go. Okay, so 1/2 to the 4th power, remember, means a half times another half times another half times another half equals x. So basically there's 4 of them because we raised to the 4th power. Remember, even though you have a common denominator, you don't need common denominators here. The way that you multiply fractions is you just multiply straight across the top and get a number, and you multiply straight across the bottom and you get a number. So if we go straight across the top, everything's a 1. Well, 1 times 1 times 1 times 1 is 1. And then we go straight across the bottom. 2 times 2 gives me a 4, times another 2 gives me an 8, times another 2 gives me a 16. And so my answer here isn't 16, it is 1/16 or 1/16 for this particular problem. All right. Okay, let's try one. This one's going to require a calculator in just a minute. We're going to get what we call an exact answer and what we call a rounded answer. But if you happen to have a calculator handy or nearby or something like that, you might want to go ahead and punch the buttons with me just to make sure that you get the correct number out of your calculator. I would love to be able to tell you the exact sequence of buttons that you can push, but unfortunately, different manufacturers of calculators do different things. And so I can't really say, hey, this is a one size fit all, everybody does this sequence, but I do want to do one so that you can make sure that you are punching your buttons in the right order. So this one's going to be one of those weird ones. So we're going to say the natural log of 7x plus 2 equals 5. So what I want you to remember is this: natural log is one of those 2 special cases. So natural log, if you will remember, means, I'm going to get rid of this for just a second. Natural log means that we have a log with the base of e. That's what natural log is. So if you prefer, anytime that you see ln, you could just kind of wipe it out of there, put in log base e. Now, your textbook's not going to do that. They're always going to write ln, but you can write log base e if you choose. So the first thing we're going to do is the first thing we did on everything else. Take it out of log, put it into exponential. So that's going to be e raised to the 5th equals whatever we happen to be taking the log of. And in this problem, that's 7x plus 2. Now, E is not a number like 2. E is that ugly, like 2.7, and it gave us really ugly decimal numbers when we were doing all of those problems on section 7.2. And so I'm not going to grab my calculator yet because Hawks often asks us for an exact answer. So what that means when they ask you for an exact answer, it means don't touch your calculator, but get X by itself. So we can do that. So we can look at this and say, okay, we have 7X plus 2. Well, I need to get rid of that plus 2. So let's do that. The way I can get rid of that plus 2 is by subtracting 2. All right, and when I do that, that's going to give me e to the 5th minus 2 equals 7x. Now, I still haven't quite solved for x. I have that 7 over there. And so the way that I'm going to need to get rid of that is to divide by 7. And make sure that when you do that, you divide the whole thing by 7 over here. And so what that really means is that if I'm solving this and giving them an exact answer, I have e to the 5th minus 2 divided by 7 equals x. And I'm going to circle this. That's ugly, y'all. But I'm going to write out right here. That is an exact answer. Exact simply means you did not round at all anywhere. You have all of the information. You didn't touch a calculator. But here's the problem with an exact answer. If you were looking for some idea of how big that number is, I don't know about you, but I don't have a clue. So to get an idea of what size that number is, we're going to need a rounded answer, and that means grab a calculator. So what we're going to do is we're going to grab a calculator. I'm going to plug in e raised to the 5th. I'm going to subtract 2, and then I'm going to get an answer because I always want to get an answer for that numerator. And then I'm going to divide by 7. And I'm going to say, let's round to 2 decimal places. And so if I do this whole number, I should get roughly 20.92 if I round it. Now, if you're trying to match this in your calculator, I'll tell you I get exactly 20.916165559, and that's where my calculator stops. It keeps going, but my calculator doesn't give me any more than that number of decimals for a rounded answer. Now, if for some reason you're not getting that in your calculator, it may be because you have a different calculator and you need to punch buttons differently. And if that's the case, then feel free to stop by a tutoring center or our office hours or reach out to us via email, and we might be able to help you get the sequence of buttons correct on your calculator. All right, let's try another one of these that takes just a little bit of extra work. That one was not the easiest thing that we have ever done. So let's see if we can find another one that might be a little tricky, and let's see what we can do. Okay, this one's also going to require a calculator. So we're going to do the same thing. We're going to do an exact answer, and then we're going to do a rounded answer. So here we go. The log of 8x equals 3.6. So that's a decimal point right there. All right, so the first thing that you should notice is this. Something's missing. Okay, well, if you remember, what's missing is my base. And anytime that a base is missing, it is an understood 10. All right, that's lovely. So now once that we know that that is an understood 10, that means, okay, we can change this and we can say, hey, that is 10 raised to this power over here. So 3.6 power equals 8x. Now that is not like saying 10 squared. 10 squared is 10 times 10. We could write that number down without grabbing a calculator, but you can't really figure out what 10 to the 3.6 is unless you grab a calculator. And so we're just going to leave that alone for a second. We're going to solve it for x. So the way that we're going to do that is divide by 8 here and divide by 8 here. So that means that if I'm looking for my exact answer, it is 10 raised to the 3.6 power divided by 8. So I'm going to circle that, and once again, I'm just going to write the word exact over here. And remember, what exact means is that we did not touch a calculator. Now, if we want our rounded answer, once again, grab a calculator. All right, the first thing you're going to do is say, okay, 10, and then remember that 3.6 is an exponent, so you're going to raise it to the 3.6 power. Now, if you do that, you should get roughly 3,981, a bunch of stuff after the decimal. But that's not all you needed to do. You needed to say 10 raised to the 3.6, and then you needed to divide that by 8. And once again, since I just did 2 decimal places on the last one, I'm going to stick with 2 decimal places on this one as well. And so if we do that, we've got x is equal to 497.63 if we round that one off. Okay. So I want you to be really careful when you're doing your homework. Sometimes Hawks will ask for both. Sometimes they will say, hey, we want an exact answer and we want a rounded answer. Sometimes they only ask for one. They say, hey, we want an exact one or we want a rounded one or whatever. You need to make sure that you're paying attention to that, because if they say we want a rounded answer and you give them the exact, even though they're equivalent, they will count it wrong. So make sure that you give them the type of answer that they are looking for in your problem. All right, I think we're going to do one more for the evening. And the reason that we're going to do this one is because a lot of times people overlook this and they think that it's a really difficult problem, and it actually isn't a really difficult problem. So I want you to look at this. The log of 8,615. So the log of 8,615 is equal to 7x. So what happens here is people try to treat this like the other problems, but this is kind of an anomaly. It's a little bit different. I want you to realize what you did on all the other problems was to solve for x. Well, if you'll notice, your x, guys, is right here. Okay, so I'm going to kind of circle it. It's over here. That's the only place your x is. What's with your x? So if you look at it, whatever's with your x is a 7x. Or a 7. So the way to solve for x is simply to divide by 7. Now, once again, if we were asking for an exact answer, this would be it, y'all. But if they're asking you for a rounded answer, you actually have to put this in your calculator, and we haven't put a log in our calculator yet. So if you'll notice when you look on your calculator faceplate, and I wish this was bigger, I wish I could kind of show you. I think maybe I can. Let's see if I can kind of do this. If you've got a TI, you'll notice that you have a log button and an LN button. This log doesn't have a base after it. It assumes that the base is a 10. This LN, remember, anytime that you have an LN means the base is an E. So your calculator doesn't have like a log base 5 on the faceplate. It only has log base 10 and log base E. That's it. So on this particular problem, we're doing log base 10. So I'm going to hit the log button. When I hit the log button on my calculator, it automatically opens a parenthesis for me. Well, I'm taking the log of 8,615. But remember, you can't forget, even though it opened it, you got to close it. It doesn't close it for you. And then divided by, so we're going to hit divided by and 7 here. So hang on just a second. I didn't actually get all that plugged into my calculator. My apologies. There we go. And if we are going to round to 2 decimal places here, that is actually going to be 0.56. Now it's actually 0.56217, blah, 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 much more stuff. But if I'm going to round it off, it's 2 decimal places. Now, if you happen to be watching this later, I'm going to give you a word of caution. You really need to go through this section pretty thoroughly. You need to go through the next section pretty thoroughly, because section 7.5, which I'm actually going to be talking about next Monday, is really lengthy. That's probably a good way to say it. And it kind of combines everything. It combines all of this stuff with things like the quadratic formula that we've already done, with things like how to solve with fractions that we've already done, all of that kind of stuff. So it basically takes everything that you've done so far for the semester and kind of shoves it into a single section. So it's got longer problems, more places to make mistakes. So make sure that you really work on this section and the next one and kind of get them down. And that way you're really ready for section 7.5 coming up. And then, believe it or not, after that, you only have 3 sections left. I don't know if y'all have realized it yet, but we're like a month away from the final. So you're kind of on the downhill stretch, which is good. And then I want to remind all of you that you need to be thinking about that project. Okay. So I know we only talked about it at the beginning last week, but there's only a month before finals. That due date's coming up pretty quick. So, and all your other classes are starting to get projects and papers and all this kind of stuff. So keep that project on your calendar. That way you don't forget about it and don't try to start it last minute because it's really not something you can do like that. All right. So be sure to let us know if you need anything, and hope you're having a great semester, and just hang on till the end. We're almost there. Night, everybody.